So this video will cover the no calculator quiz review we got in class today. This is, of course, in preparation for your quiz tomorrow. Again, since this is a no calculator quiz, we should be doing this review with no calculator. So you will notice I do not have a calculator here with me. But I will be talking through some strategies you could use if you did get stuck on something you would normally use a calculator on. So, that being said, number one, I will admit I didn't really catch this before this went out on the sheet. 225 is probably a pretty big number to know the square root of off the top of your head. I mean, I hope that some of you do. The square root of 225 is 15. Okay, but let's talk about what we could do with this if we didn't know the square root of 225, if we were in a panic moment and we didn't know what it was. You can take that square root of negative 225 and break it down just like we've broken down all of the other square root problems we've done. So the one I saw today, well, first of all, we would take out a square root of negative 1. Okay. A lot of people found it easy to divide 25 into this because they knew that 25 goes into 100 4 times. So it would go into 200 8 times and then tack on one more 25 to get to 225. So 25 times 9 would give you 225. Okay, again, think about 9 quarters. You would have $2.25. Well, all three of these can be simplified, right? This would come out to be a 5. This would come out to be a 3. And square root of negative 1 would come out to be an I. So put the 5 and the 3 together, I get 15. And so this becomes 15I up on the top. And again, not that you have to do that process for every single one of these, but if you found 225 too hard to come up with in your head, this would be a great way to go. Something like this, square root of negative 25, I would hope that you wouldn't need a calculator or a breakdown or anything. I hope you just look at that and you know that that's equal to 5i. Okay, so I have 15i over 5i. From there, I can cancel out my i's above and below. Okay, and then 15 over 5, I'm going to actually divide those two and make 3. And that would be my final answer there. Okay, so something like number 2 is a little more reasonable. For number 2, square root of negative 36 would give you 6i. Square root of negative 64 would give you 8i. And again, I'm getting i's because I'm doing square roots of negative numbers. Okay, again, my i's are going to cancel out. And I'm left with 6 over 8, which would reduce to 3 over 4. So you do want to reduce your fractions as far as you possibly can. If they don't reduce, leave them alone. But you won't want to use decimals or anything, but you can reduce fractions. Okay. All right, let's take a look at number 3. That's a pretty classic FOIL problem there. So I'm going to go 2 times negative 4 is negative 8. 2 times 6i is 12i. Negative 3i times negative 4 makes positive 12i. This is the one that always catches people. Negative 3i times 6i. Well, negative 3 times 6 is negative 18, and I times I gives me I squared. So I multiplied those 4 pieces out. Now, here are some things I can do to clean this up. First of all, my i's in the middle can combine. Okay, so 12i and 12i, that's going to make a 24i. I can also take this negative 18i squared, because remember, I squared is really like negative 1, and just replace that with a plus 18, and then that plus 18 can be combined with the negative 8. So I end up with negative 8 plus 18 is 10, plus, and then 12i and 12i is 24i. And that's where I would leave my final answer. Okay, so same thing with number 4. Number 4 is going to be a FOIL problem. So negative 6 times 4 is negative 24. Negative 6 times I would leave me with negative 6i. Negative 2i times 4 would be negative 8i. And negative 2i times I is going to give me negative 2i squared. So I'm going to combine the 2 i's in the middle, the negative 6i minus 8i, I'm also going to take this minus 2i squared and replace it with a plus 2. And that's going to combine with my negative 24. So I'm going to end up with negative 22 minus 14i. Okay, so next one, 10 plus or minus square root of negative 100 over 5. Well, the first thing I would do is say, I know that the square root of negative 100 is 10i. That should be a pretty obvious one, right? And now this 5 down here means that I'm dividing this by 5 and I'm dividing this by 5. So 10 divided by 5 is 2, plus or minus, and then 10i divided by 5 is 2i. And that's just where I would leave my answer. Okay. So again, similarly in number 6, I'm going to take that negative 144, square root of negative 144, and replace it with 12i. And again, it has an I because it's a negative number under a square root. And then I'm going to take each one of those and divide it by 4. So negative 8 divided by 4 is negative 2, and 12 plus or minus 12i divided by 4 is 3i. And there you go, simplified. Okay, number 7 is really just a test of your algebra skills. I'm going to start on the left there by distributing that 3. So I'm going to end up with 6 plus 9i plus, and then over here I have to FOIL. So 6 times 1 is 6. 6 times 3i is 18i. Oops, 18i. Negative 2i times 1 is negative 2i. And negative 2i times 3i makes negative 6i squared. Okay. I would immediately take this negative 6i squared and replace it with a plus 6. Okay. And then I'm going to go through and I'm going to collect all of my real numbers. So 6, 6, and 6 make 18 plus, excuse me, 9i plus 18i minus 2i. Let's see, that's 27 minus 2 is 25i. And there's my final answer on that one. Okay. Okay, so number 8. These are just basic square roots of negative numbers, okay? And we know that when we take square roots of negatives, we can just take a square root. It's 2, but then because it's negative, it gets an I. So this is 2i times 4i. Well, just like what we've been doing up above, 2i times 4i would give me 8i squared, which would then translate into just negative 8. So anywhere you have an I squared, you end up with a negative 1. Not just an I, but an I squared turns things negative. Okay, up to number 9. Tricky thing with number 9 is this minus sign right here. Make sure that gets distributed. So this is going to be a minus 4, but it's going to be minus a negative 5i. So really we need to think about it as a plus 5i. So negative 2 minus 4 gives me negative 6. And then here 3i plus 5i, or you could think of it as 3i minus negative 5i. Either way, it's going to give you 8i. Okay, these next two are ones I got a lot of questions on today too. So first of all, I want you to see the difference between this and this. See how this one has addition and subtraction in it? You can't just cancel the i's out when you've got pluses and minuses going on in there, because when you've got that, that all counts as like one chunk, and you can't get rid of it unless you can get rid of the entire chunk. So we do need to get rid of this I on the bottom, okay, because we don't like having i's in the denominator. So what I'm going to do is I'm going to multiply by something called the complex conjugate. And that's where you take the complex number and just switch the sign in the middle. Okay, and you'll see why that's important in a minute. And then I'm going to multiply by that exact same thing up on the top. From there, I'm just going to FOIL straight across top and bottom. So on the top, 4 times 3 is 12. 4 times 6i is 24i. 2i times 3 is 6i. And 2i times 6i gives me negative 12. Well, I'm sorry, positive 12i squared. Okay. On the bottom, 3 times 3 is 9. 3 times 6i is 18i. Negative 6 times 3i, so sorry, I've already done this and that, so now I'm doing this. Negative 6i times 3 is negative 18i. And negative 6i times 6i would be negative 36i squared. Okay? So FOIL on the top, FOIL on the bottom. On the top, I'm going to combine these two. I'm also going to replace 12i squared with a minus 12. On the bottom, I'm going to combine these two, and when I do that, they cancel out, which is exactly what should happen. And then this negative 36i squared, I'm going to make a plus 36. Now, there is something kind of strange and unique that happens in this problem that doesn't always happen. In fact, it rarely happens. When I go to combine my whole numbers, I have a 12 and a negative 12, and they actually cancel out as well. That doesn't always happen. Don't expect it to happen. But here you end up with a 30i on top, and let's see, this is 9 plus 36, so 45i, or sorry, not a 45i, just a 45 on the bottom. And then I want to simplify 30 over 45 like a fraction. Okay, so 15 goes into both of those, and this would reduce to 2i over 3, or you could think of it as 2/3 I. Okay. Okay, so number 11 we're going to attack in much the same way. So let's multiply by the conjugate on the top and on the bottom. So I'm going to multiply by 1 plus 2i and 1 plus 2i. So that's going to leave me with negative 3 times 1 is negative 3. Negative 3 times 2i is negative 6i. Negative I times 1 gives me negative 1i. And negative I times 2i gives me negative 2i squared. All over 1 times 1 is 1. This will give me 2i, and this will give me negative 2i. And then negative 2i times positive 2i gives me negative 4i squared. Okay, and just like before, let's combine and simplify. So I end up with negative 6i minus I. This negative 2i squared can become a positive 2. Here, these ones, when I combine them, they cancel out, which is what I wanted to happen. And negative 4i squared just becomes a positive 4. And so when I put everything back together up on the top, negative 3 plus 2 is negative 1. Negative 6i minus I is negative 7i. And on the bottom, I'm left with 1 plus 4 is 5. And this is right where I would leave my answer. Okay, let's keep going. Number 12. Just like before, I'm going to distribute here. So distribute negative 9 in here. It's going to give me negative 54 minus 36i. Be careful when you distribute here that you include that negative with the 3 when you distribute it. So negative 3 times 5 is negative 15. Negative 3 times negative 3i is positive 9i. And then just like before, let's combine. So negative 54 minus 15 is going to give me negative 69. And negative 36 plus 9 gives me negative 27i. Okay. All right, so 13 and 14. These are not ones like numbers 1 and 2, where the numbers were nice perfect squares under the radical, and we could just take a square root and tack on an I. 80 doesn't have a nice perfect square root, so we have to do what's called simplifying here. And that's where I want to look for the biggest perfect square that goes into 80. Okay? Now, if you're efficient, you will know that 16 actually goes into 80. So I could rewrite this as negative 1 times 16 times 5. So 16 times 5 gives me 80, and then I've got a negative 1 out there to make it negative 80. And then I'm going to do the square root of each one of those things. So this is going to give me I. This is going to give me 4. And this is just going to stay square root of 5. Which means the proper way to write that would be 4I square root of 5. Okay? Now, let's say on that one that you didn't know 16 times 5 was 80, because that's not a super common one. Okay? I might go down here into this blank space and try out another scenario here. So let's say you didn't catch 16 and 5, but you knew you could do 4 and 20, and 4 is a perfect square. So you might have said, well, 80 could be written as negative 1 times 4 times 20. Okay? And you would have been correct. So square root, square root, square root. This would have left you with an I, this would have left you with a 2, and this would have left you with a square root of 20. And that's all fine and good, except 20 can be reduced further. Okay? You could take that 20 and write it as 4 times 5. Okay, so then square root of 4, square root of 5. That square root of 4 can become a 2. You already have an I and a 2 out here. And then you have a 5. Square root of 5, I should say. Put that all back together and you get 4I square root of 5, just like before. So, if you didn't catch that right away, if you didn't know that 16 was a factor there, you could still catch it by doing a 4 and then another 4 later on down the road. All right, let's take a look at 14. Again, I want a perfect square that goes into negative 500. So I would probably think about this as, first of all, a negative 1, just because we know it's negative, and then a 100, and then a 5. Okay? And these two, I can do something about. I can make this an I can make this a 10, and this is just going to stay square root of 5. So I can write my answer as, where should I put it? 10I square roots of 5. All right, one more on this page. So this one is basic again, just like number 1 and 2. Square root of negative 16 we would say is 4I. Square root of negative 9 is 3I. And then add them together and I get 7I. What you do want to be careful on this one, the whole reason it's on here, is to point out that you can't add together under the radicals unless they're common. Okay, so I can't say, oh, negative 16 and negative 9, that's negative 25, and then just do a square root of that. You can't combine radicals with addition. Okay, you can only combine them with multiplication. Okay, so on this one you would have to solve them each separately, or evaluate them each separately, add them together, and be done. Okay? Okay, so I'm going to, right now, get this video posted, and then I'm going to start a second video on the back side of this page, which I guess many of you will probably end up needing some help with. And when I'm all done, I'll also post this printed answer key, so you can just use it to check answers if you want to.